Okay, the last section is simulation. A lot of times we're going to use the graphing calculator really to help our simulation today. So you can follow along with mine, just so you can kind of see how it's done. So a simulation is the imitation of chance behavior based on a model that reflects the experiment. So we're going to do two of them today. So an unprepared student takes a true-false quiz. If she guesses randomly, find the probability of getting at least 5 out of 10 correct using a simulation. We're going to learn how to do this in Chapter 7 without the simulation. But today we're just going to use the simulation. So the first step in a simulation is to state the problem clearly. So you just want a general statement. So if a person is guessing on a true-false quiz, what is the probability they get at least 5 out of 10 correct? So, identify your assumptions. So there's a few things we're going to assume. First of all, we're going to assume it's a 50-50 chance of getting a question correct. So, what that means is we're going to assume that the student has no prior knowledge they're just blankly taking a true-false quiz. And then we're also going to assume each question is independent. So she's not going to say, okay, number one, I don't want to do all false, or I don't want to do all true. We're just going to assume each one's independent. So we can model the outcome. You can either flip a coin. So I could flip a coin 10 times. And then if it's heads, they got it right. If it's tails, they get it wrong. I could use a random number table. An odd number would mean they got it right. An even number would mean they got it wrong. But what I'm going to do today is a random number generator. So here's how I'm going to simulate the trial. So on a random number generator, I will use numbers 1 and 2 and take 10 numbers at a time. A 1 is meaning they got the answer right. A 2 means they got the answer wrong. So correct, incorrect. A set of 10 numbers is one trial, which is one quiz. Okay, so here's how we're going to do it. We're going to do 10 trials. So I'm going to have trial 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to have trials 1 through 10. So if they get 5 or more right, I'm going to put a check mark. If they get 4 or less, I'm going to put an X. So in my calculator, what I'm going to do, I'm going to go to Math, I'm going to go to PRB, and I'm going to go to Rand Int. So I'm going to do 1, 2, because I'm only picking numbers 1 and 2, and I'm going to do 10 at a time. So my first trial, I get 1, 2, 3, 4 right. So 4 out of 10, that would be an X, because I had 4 ones. I hit enter. Now I have 1, 2, 3, 4, 5 out of 10. So I'm going to put a check mark, because I got at least 5 right. 1, 2, 3, 4. So 4 out of 10, nope. 1, 2, 3, 4, 5. 5 out of 10, nope. 1, 2, 3, 4, 5, 6 out of 10. Oops, this should be a check. Check, check. I got 5. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, 6 out of 10. We're good. 1, 2, 3, 4, 5. 5 out of 10. We're good. 1, 2, 3, 4, 5. 5 out of 10. We're good. 1, 2, 3, 4 out of 10. We're not good. 1, 2, 3, 4, 5. 5 out of 10. We're good. Okay. So we simulated us taking 10 quizzes and just guessing, and this is how many times we got things right. So, of the 10 trials I ran, now each one's going to be different, and what I would usually do is have the students do this on their own, and then they would complete the sentence on their own. So, 1, 2, 3, 4, 5, 6, 7 times the student would have gotten at least 5 out of 10 correct. So my experimental probability is 70%. Okay. Now, it's going to be different for each student for each simulation. But what should happen if I combine them all is the more trials there are, the more trials we run, the closer we get to the theoretical probability, which we'll learn about in chapter 7. But if I think about it, I could probably come up with it. But I can't think about it right now. Oh, there it is. It should be close to 60%. So I got 70. But we'll get to theoretical probability, like I said, in chapter 7. Okay, so this works well. I can pick 1 and 2 if it's a 50-50 shot. On the back, we're going to look at what happens if it's not a 50-50 shot. So a basketball player makes 70% of her free throws in a long season. In a tournament, she shoots 5 free throws late in the game and misses 3. Was she nervous or were they missed by chance? So again, our problem here, if a person has a 70% free throw rate, what is the probability they will miss 3 out of 5 shots? So there's just a couple assumptions. And really the important part here is to know the assumptions. Again, each shot is independent, just like each question was independent. We know that she makes 70% of the shots she takes, which means she misses 30% of the shots. Okay, so model. So here's how we're going to model this using a random number generator. So, random number generator. So I'm going to use the digits 0 to 9, so I can just stick with one digit. 0 through 6 is going to be that she made the free throw. Okay, that's 70% chance. If I get a 7, 8, or a 9, that means I missed the free throw. So there's my 30%. And the biggest takeaway from this section is really not doing the simulation, it's really setting it up. Because you want to make sure that you are able to describe like what 70 to 30% would be. So one trial here is going to equal 5 numbers because she takes 5 shots. Okay, now here's where it gets tricky. So she made 2 or less. I'm going to put a check because it said she missed 3. So she made 2 or less, I'm going to put a check. If she made 3 or more, I'm going to put an X. Okay, it's kind of like I'm going to work backwards. Okay, because I want to see if she was nervous. So if the more X's I get, that means that she was more nervous. The more checks I get, that means she was fine. Okay, so for my trials. Again, I'm going to do 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, sometimes it's easier to write out the numbers, so this might take a little while. But again, I would have the students do this individually. So again, I'm going to go to Math, Rand Int. I'm going to go 0 to 9. I'm going to do 5 numbers at a time. Okay? So here, so 0 through 6, she made it. So she made, missed, made. So this first one, 3 out of 5, she made, so I'm going to put an X. Made, 2 out of 5. Put a check. Made, so 4 out of 5. X. Made, oh, she made all of them. X. 4 out of 5 here, so X. Oh, no, 4 out of 5. I was counting 6. Okay, I'm gonna keep going. Trial 6, she made all of them except for the last one. Here she made 2 out of 5, so again I'll put a check because made. 4 out of 5, so I'm going to put an X. 4 out of 5 again, so I'm going to put an X because the 7 in both of those is the only one she made. Or missed, sorry. And then missed, made, so 3 out of 5. So I'm going to put an X. Okay, so there's my trials. So based on the trials we ran, the basketball player made 3 out of 5 shots. So if I look at all the X's, she made 3 out of 5 shots 80% of the time. So the fact that she missed that many means, therefore, she was probably, I almost said probability, probably nervous. So again, the important part about simulation is it's a very, very small section of the AP exam. Usually it shows up on the multiple choice, and normally what it is in the multiple choice is either setting it up, the modeling part, or here's my info, write a conclusion, or the assumptions. Not necessarily am I going to make you do 10 trials, mostly because you don't have the time on a quiz or a test to run all the trials. So that's really it for Chapter 6, though. Again, a lot of it's just doing problems, not a whole lot of formulas. The only formulas you do need to know for Chapter 6 are obviously the 2 that are right here for general probability. We'll get to this table in Chapter 7.